Okay, let's check this one out. So I'm definitely working on the left side, it looks like. Looks like there's probably a lot of stuff I can simplify there. Well, sine is well, let's do that. Let's rewrite it as, now sine squared minus cosine squared, by the way, is not -1. Okay, sine squared plus cosine squared is a +1, but it can't manipulate that in any way, so that way it gives me exactly sine squared minus a cosine squared. Okay, so this isn't just like, oh, it's an easy Pythagorean identity. It's not. Oops, didn't mean cross that off. So if I go through and think about, well, sine squared is the same thing as sine of the angle, and then I'm squaring that, and I've got minus cosine of the, apparently the opposite of the angle, and I'm squaring that, divided by, I also recall that sine is an odd function. So the sine of negative theta is negative sine, and minus, that comes from this subtraction sign, just bring it down there. Cosine, though, in and of itself is an even function. So the cosine of negative theta is, in fact, just cosine theta. Okay? Then I have the right side is the same. Let's see here. Sine, we just said sine is a negative angle, or an odd angle. So sine of a negative angle would be negative sine theta. And I'm taking that and I'm still squaring it. Minus cosine, though, is an even angle, or an even function. So this is going to be a minus, and that's not going to change in there. It's just going to stay as cosine theta. And I have that squared divided by denominator. What can I do with that? I don't know. Not a whole lot at this point. Maybe I could factor out a -1. How about that? So if I factor out a -1, then I'll have sine theta plus cosine theta down there. And notice how you're not dropping the equal sign on the right side. Keep it there, please, as you're going down. So if I take something that's negative and I square that, that turns into a positive. So it'll just become sine squared theta now. Minus cosine squared, or maybe I'll leave it like how I had it. I think I'm going to leave it like this. This is sine of theta squared. Okay, what I wrote before wasn't wrong, but just maybe this will help you visualize it. And then I also have minus cosine theta squared divided by, same thing on the denominator here, equals that right side. Now if you want to write cosine theta minus sine theta, cosine theta, oops, not there, cosine theta minus sine theta, for all of these, that's fine. Or if you want to draw an arrow to indicate it's continually going down, that's okay. But if you just want to leave it blank, I'm all right with that. But just don't drop the equal sign, okay? So then I'm seeing the numerator is like a difference of two perfect squares. So it's like sine plus cosine theta plus cosine theta times sine theta minus cosine theta divided by -1 times sine plus cosine, which is convenient, that difference of two perfect squares factoring, because now I've got a sine theta plus cosine theta on the numerator and denominator. So then if I take sine theta minus cosine theta, which is what is left, and I divide it by this -1 down here, that'll leave me with a negative sine theta plus cosine theta, which looks almost like what we had originally. Okay, rewrite it so that way it looks the exact same as the original. And I've got cosine theta minus sine theta equals cosine theta minus sine theta. So thus, check, I have in fact verified that this is cosine minus sine. So now we're going to establish these identities. On this first one here, though, why does that? I don't like how that's, whatever. I can't get rid of it, I guess. I'm sorry. Oh, there it goes. On the first one, my first inclination here was to think about, well, if I multiply top and bottom by 1 minus cotangent, that'll leave me with a 1 minus cotangent squared. Oh wait, that looks a lot like a Pythagorean identity. And then when I came back here and looked at my Pythagorean identities, 1 minus where did they go? Where did they go? Oh, there they are. 1 minus, oh, wait a minute. I only have a 1 plus cotangent squared, not a 1 minus cotangent squared. So then I realized, well, that doesn't really work. So my initial plan was to multiply the top and bottom here by the conjugate of this, would be 1 minus cotangent theta, but it doesn't really get me anywhere. Because that identity is 1 plus cotangent squared, not 1 minus cotangent squared. So then my other thought was, well, what if I know a relationship between tangent and cotangent. Cotangent is a reciprocal of tangent. So if I make this as 1 plus tangent theta divided by 1 plus, and all I'm doing is changing cotangent to 1 over tangent, being that this side is in tangent. Now I could change this all into sines and cosines at this point, but I'm thinking that could get really messy. Then I'll have 1 plus sine divided by cosine divided by 1 plus 1 over sine over cosine. So then I got fractions over other fractions over other fractions. So that's a lot of fractions and fractions. I would avoid that for right now and make that a second option for me. That if I totally get stuck, maybe I'll go back and try that. You'll definitely want to have an eraser with you when you're doing these. Mr. Cole, you will want to have an eraser when you're doing these, or an erasable pen, because you're going to be doing some erasing, I promise you. So what if I make the the denominator, what if I make that as one single fraction? So what if I think about that like 1 over 1, and then get a common denominator by multiplying this by fancy looking number 1, tangent divided by tangent. So then I'll have a common denominator of tangent, and the numerator will be tangent plus 1. Well, that looks bad. Well, maybe, maybe not. Maybe something will cancel here. So if I have the numerator, and that's really the same thing as dividing, maybe I'll write it out one time, divided by tangent theta plus 1 over tangent theta. And then how do I divide fractions? So I have this, I put that in parentheses on purpose, times that reciprocal. And then I notice that there's a 1 plus tangent on the numerator and denominator. Oops, I don't know why I wrote a equals 1 there. So then on the left side, I'll just have tangent theta, and on the right side, that was also tangent theta. So now I've checked, I've verified that identity. Biggest thing with these identities, verifying identities, is just practicing with them. So here's an opportunity for you. I want you to pause the video right now, and I want you to do this one. Okay? No, seriously, pause the video, take 5 minutes, see if you can't figure it out. Which side should I work on? Well, they both look equally as hard to me. It doesn't matter. Try doing this one. You did it? I hope so, because I'm about to do it now, okay? And it doesn't really help you if you just are watching and you haven't tried it. You're going to learn it by just practicing these. So my first inclination here was thinking, well, boy, this is a 1 minus sign. That's so close to being like sine squared plus cosine squared equals 1. If I just subtract off a sine squared on both sides, then I would have cosine squared is 1 minus sine squared. And that would help me really relate, I think, this cosine to turning, like if I make that numerator somehow in terms of cosine. But the problem is I don't have 1 minus sine squared, I only have 1 minus sine. So what I could do here is, what if I multiply the top and bottom by 1 plus sine theta? Which, kind of foreseeing over here, I do have a 1 plus sine theta, so I need that down there anyway. So on the numerator, I would have a 1 minus sine squared, and on the denominator, I'll leave it factored. And let's see here. Oh, the numerator. Hey, I know that. That's cosine squared, right? Cosine squared is 1 minus sine squared. So I've got cosine squared on the top. Denominator, let's leave that factored. And then, well, this is the same thing on the top as cosine theta times another cosine theta. So I've got 2 of those up there. So if I get rid of one of them, then I'll have cosine theta divided by 1 plus sine theta. And that was my goal all along. Now, if you worked on the other side, I'm sure that you could get it to work out too. Maybe if you try multiplying the top and bottom by 1 minus sine theta, it should work very similarly to what we just did here. Well, that's it for the start of verifying trig identities. We'll be doing lots more of them. Hope that you're enjoying doing these puzzles. And this is April Ann Rainey. I'm signing off, and I will see you tomorrow.